Alright, example 3. Find the vertical asymptotes by using limits. Graph the function. Okay, determine all the vertical asymptotes of the graph. And we're going to do that by using limits. So how I want you to do this, first of all, let's factor this. So let's look at the numerator. This could be x plus 4 times x minus 2 all over x plus 2 x minus 2. Okay, so from college algebra, if you remember, this right here, this x minus 2 divided by x minus 2, this is telling you that we have a hole. Okay, so we have a hole at x equals 2, and to figure out the y value, we would plug x into the function after we reduce it. So the reduced function would be x plus 4 all over x plus 2. If I plug 2 into that function, it's going to be 6 over 4, which is 3/2. So now we know we have a hole at 2 comma 3/2. Okay? And then this x minus 2 from college algebra, we know that we have a vertical asymptote at x equals -2. Also, using college algebra, we know that the horizontal asymptote is going to be y equals 1. Since the degree of the numerator is equal to the degree of the denominator, we look at the leading coefficients, which is 1 divided by 1, which would be 1. Okay. So now let's start to graph this function. And then we'll use one-sided limits to describe the vertical asymptote. Alright, so let's graph the vertical asymptote at x equals -2. Let's graph the horizontal asymptote at y equals 1. And now let's see how this graph is going to look. We're going to see how this graph is going to look by doing a table. So let's start over here somewhere. Let's start off when x is -3. When x is -3, I'm going to plug it into this. This would be -1 times -5 all over no, this would be +1, this would be -1, and this would be -5. So overall, this is going to be -1. So at -3, -1, I have a point. So the graph is going to look like that in that region. Then let's pick a point on this side of the vertical asymptote. Let's try 0, because 0 is going to be easy to plug in. I plug 0, I'm going to have 4 times negative 2 all over 2 times negative 2. So this is going to be 2. So 0, 2. Also, sorry, 0, 2. Also, remember at 2 and 3 halves, which was right here, that's going to be your whole. So this part of the graph is going to look like that. Now we have this graph. Now we can use the graph to use one-sided limits to describe the vertical asymptote. So first of all, let's start right here. If I use one-sided limits, the limit of this function as x is approaching negative 2. So as x is approaching negative 2 coming from the right, this is going to equal positive infinity. And then if we look over here, if I look at the limit of this function as x equals negative 2 coming from the left, that's going to equal negative infinity. This description of the one-sided limits here tells us that we have a vertical asymptote at x equals negative 2. The reason why is we're taking x as it approaches negative 2 from the right, it gives us infinity. And then here we have x is approaching negative 2 from the left, and it equals negative infinity. So there has to be a vertical asymptote at x equals negative 2.